Hello everyone, welcome back to the channel. We are doing lead code 1007 minimum domino rotations for equal row. It says in a row of dominoes, tops of I and bottoms of I represent the top and bottom sides of the ith domino. So I have some amount of dominoes. In this example, I have 6 dominoes. In the other example, I have 5 dominoes. So this is the top side of the domino and this is the bottom side of the domino. So one thing that we are learning over here is that the top and the bottom sides can be equal as well. For example, in this scenario and in this scenario, right? A domino is a tile with two numbers from 1 to 6, one on each half of the tile. So one number is on the top, another is at the bottom. We may rotate the ith domino so that tops of I and bottoms of I swap values. Okay, so what we can do is we can either convert a top to a bottom or vice versa, a bottom to a top. Okay, return the minimum number of rotations so that eventually all the values in the top are equal or all the values in the bottom are equal. So either the top row is equal or the bottom row is equal. And if this cannot be done, if it's not physically possible to make all the values equal, we need to return -1. So without further ado, let's actually have a look at the test cases. So for example, you see I have 2 over here, I have 2 over here. I could bring this 2 upwards, you know. I have okay, why is this not, anyhow, I can bring this 2 upwards. Then I have this 2, okay, I have a 2, I can bring it upwards. I have this 2 and I have this 2. So if I make this one change and this as the second change, then everything works for me, isn't it? And these are the two changes that I'm making. I could have also brought this downward, brought this downward, brought this downward, brought this downward, but then not this, actually both of them are 2, but then that would have taken me 1, 2 and 3 number of operations. So you see 2 is actually better than 3, right? That's why we are going with the top row. Okay, perfect. Let me just erase these configurations. All right. Then if we take a look at the second test case, then there's this 3 3 5 1 2 3 6 3 3 4. Yeah, perfect. So I have 3 over here, sure, I have 3 over here, 3 over here, 3 over here, but this column I cannot make equal to 3. So this was actually a very 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 important test case, and it actually made the question very much clear to us. It basically very simply means that in each of these columns you need at least one number to be equal throughout all these columns, isn't it? So for example, if one of these, either 5 or 6, if one of these was a 3, then it would have been game for me, isn't it? Right? For example, if this was 3, then I would have had to make two operations. Or let's say if this was 3, then also I would have had to make two operations, but I would have had to make just a one operation, convert this 3 into 4, because this row is actually equal. And that is another observation, actually, that is observation number 2. Observation number 2 is that there could be a scenario where both the up tile and the down tile are equal, so you do not need to make any change, right? You don't even consider it as a column in the first place. If if both of them are equal, one thing, they are equal, and the other thing is that they are also the most common element. What do I mean by the most common element? I simply mean the one which is uniform, which is common throughout all the rows. So 2 2 2 2 2, and I have 2 over here as well. Say, so that was a good thing. If this wasn't 2, then I would have had to return -1. You see my point? So again, intuitively, totally intuitively, if we follow our gut feeling on this particular test case, then what am I actually doing? I am recording what numbers do I have in each of the column. So why don't I take a map for it, right? I will take a map which is int comma int. All right. My gut feeling tells me that I need to track their frequency, which obviously I need to do. So I'll take a map for it. Sure. Now I have 2. Okay. Okay. So I will increment the frequency of 2 by 1. I have 5 as well, so I will increment the frequency of 5 by 1. I have 1 and 2, so 1 and then 2 becomes 2. Okay, perfect. Then I have 2 and 5, so 2 and 5 will become, sorry, I have 2 and 6, so 2 and 6. Okay, then I have 4 and 2, so 4 and 2. Okay, then I have 2 and 3, so 2 and 3, and then I have 2 and 2. Now the thing is, both of them are equal, so I shouldn't do the frequency 7. No, what I will do is, what I did in my approach is, if both of them are equal, if top is equal bottom, if both of them are equal, I'm just going to count it once. Okay, so the frequency of 2 becomes equals to 6. What I'll do is, however many conditions are there such that top is equals to bottom, I will store the index in a set. So the index is 5, I will store it in a set. Why am I doing that? We'll come to know. But at this point, I have the frequency map. So I have two, I had 5, 1, 6, 4, 3, so on and so forth. I had all these individual numbers, but then there is this single number, this particular number, which is appearing exactly how many times? Which is appearing number of column times, these many times. So you can say basically it is appearing column times, however many the number of columns are. And that means that I do not necessarily have to return -1, making the answer is possible. So what I will do is, first of all, I need to extract this 2. I need to be able to extract this 2 as the most common element. Okay, I will say that 2 is the most common element. Okay, perfect. That works in my favor. And then what I will do is, the only thing which is left for me to do is, I now need to calculate the minimum number of operations. So whether I need to turn the tops to bottom, so for example, this here, then this here, then this here, this remains as it is because both of them are same, so it would take me 3 operations, versus if I move upwards, it's going to take me 2 operations. So I need to be able to do this particular logic. How am I going to do that? It's going to be very simple. I am going to iterate in the tops array. Okay, 2 1 2 4 2 2, and I am going to count how many instances of the most common element do I have in the tops array. Alright, I'm going to do that. So 1 instance, okay, 2 instance, okay, third instance, alright, very nice, and wait, this is the same index as this one, so I am not going to count it. Okay, that is why basically I took the set, so that I could very easily ignore the columns which have both of these as the same. So if both of these are the same, there is no need to swap, right? Because obviously it's not going to be of any use. So why swap? So I'm not going to regard this. That is why I took the set. So this is 3, right? If I'm coming from top to bottom, that tells me that I would need 3 operations, versus as compared to I will need only 2 operations if I'm going from bottom to top. So what I'm going to do is, I'm going to take the minimum of this particular count. You can say the tops count. Okay, let me shorten it for T. And what's going to be the other thing? Think about it. You see, if I take the number of columns n, and there is this one single column which is not going to be swapped, so I'm just going to subtract the size of set from n, so that I'm talking about this particular space actually, and not this. I'm talking about this particular space. And if I subtract 3 from it, so basically T from it, what will I get? I will get the number of operations that I need to do in order to go from bottom to up. So I just need to return the minimum of these two numbers. It's as simple as that. As simple as that. You see. So over in this scenario as well, what's going to happen is I'm going to first of all keep track of the frequency, right? I'm going to keep track of the frequency. So I will have both of these are the same. So I will have 3 and 1. I will have 5 1 and 3 2. Sorry, this was 6 actually. Sorry, 6 and 1. Then I have 1 and 3. Okay, then I have 2 and 3. So 2 and 3, and then I have 3 and 4. So 3 and 4. Now you see, the thing is that the most commonly occurring element, the most common element is not actually occurring n times. It should have been present in each of these columns. It's present in 4 of the columns but not in this column. So there is no way that you can sort of have 3 over here, because you need to make the same row, either the top row or the bottom row. So since this is less than n, I'm just going to simply return -1 without any further processing. Okay, so we are going to do exactly this. We are going to do exactly this now inside of our code. Perfect. So what I'm doing is I have taken a map over here. I have taken an element which is mx, basically tells me the maximum element that I have. This mx basically tells me the frequency of the maximum, the frequency basically of the most commonly occurring uh, element, so that I can just rather than going through the map, I can just directly compare the mx with n and see if I need to return -1 or not. All right, then I have taken n as tops dot size, and what I'm doing in this loop is I'm iterating over each of these entries individually. So first of all, what I need to do is I need to be able to track their frequencies, and there could be two cases for that: if top is equals bottom, or if both of them are different. So if top equals bottom, what I'm going to do is I'm just going to I'm not going to increment the frequency of top by 2. I'm just going to increment it by 1. So there's that. Okay, all right. Then what I'm again doing is I'm keeping track of the maximum frequency which I have encountered till this point. And after that, I'm just going to see if the maximum frequency in this scenario, you see it was 4, so it was less than n. But then in this scenario, it was 6, which was not less than n. So if the maximum frequency which you have encountered, if it's less than n, just do not think about anything else. Just return -1. Okay. So we do that. Then I take then I basically iterate over the map, and I see if row dot second equals n. So I'm iterating over the map, and this logic is basically in order to find out the most common element. I need to see which is the number which has the most common element frequency. So if row dot second equals n, what do I do? If row dot second is equals to n, I record that number row dot first, and I break out of this loop as soon as that. So in this scenario, my number is going to be 2. My number is going to be 2, and in the other scenario, I won't have any such number because I would have already returned -1 from here. Perfect, everything works. Then I take answer as 0. I iterate over the tops array, just like I said, and I'm going to compare if the current number in the tops, if it's equals to number or not. If it is, I'm going to do answer plus plus, and just like I said, I'm just simply going to return the minimum of answer and n minus answer. But then you see this particular logic is missing the set, is missing the set logic. So the columns which you do not need to swap. So if I run it for the example test cases, there is this very interesting test case which fails, which actually led me to which I did not think of the set logic in at the start. This test case led me to think of it. So you see, I'm iterating in the tops. I'm seeing if I equal numbers, and I'm doing ans plus plus. So in this scenario, it is going to become 1, 2, 3, and 4, and I'm returning 4, whereas I should have just returned 1. Why? Because both of these, this 2, this column and this column, they're equal. So I do not need swapping over these three columns. I just need to swap this one single column. So that is why what we are going to do is simply add some logic over here. So I'm going to turn up braces over here, sorry, and I'm going to say that st dot insert the current index, and I also need to be able to make a set over here, set of integer st. Perfect, that works. And what I'm going to do is I'm going to say, first of all, I need to be able to convert this loop to I equals 0, I is less than n, and I plus plus, because I'm basically storing indexes, right? That's the thing. So yeah, there's that. And I'm going to say if nums of I equals number, you do, and also st dot find index should be equals to st dot end. So the index which you are talking about, should not be present in the set. So basically, if that index is present in the set, that means, sorry, not nums of I, tops of I. If the index which you are talking about, if it's present in the set, then that means that column needs not to be swapped. Okay, that column needs not to be swapped. So that's why I'm checking this particular condition. What's wrong? It's saying the output is 3. Oh, sorry, I forgot to say st dot size over here. Yeah, I should do that as well. Compilation error. Yeah, I need to be able to make it into a variable first. I'll just say set size is equals to st dot size, because this error is probably related to the type. St dot size is not an integer or something like that. I have encountered this error previously as well. So rather than typecasting, I'll just make a variable out of it. So it passes all the test cases, and if I submit this code, let's see if it passes all the available test cases that there are. It very clearly does. And now if we take a look at the time and space complexity, then you can very clearly see that we are taking a linear space complexity, isn't it? We are taking a map and we are also taking a set. So in the map, obviously I'm going to keep track of all the numbers that there are in the tops and bottom array. And in the worst scenario, the set could have all the possible numbers. So there's this O of n extra space that I'm taking. And if we take a look at the runtime complexity, that is O of n as well. Why? Because at the very most, I visit each and every number over here once, when I'm keeping track of their frequency, and that's it. I maybe visit all the numbers over here, but then the runtime complexity is very clearly O of n. It's not greater than linear. So I hope you found this video helpful, and I will see you in the next one.